This is M. Prithviraj from ECEB. Today I want to tell about Cauchy's mean value theorem in linear algebra and calculus. We have the outline, introduction, statement of Cauchy's mean value theorem, applications of Cauchy's mean value theorem, examples for Cauchy's mean value theorem, solving and conclusion. We have the question, state Cauchy's mean value theorem and find C of Cauchy's mean value for f of x equal to root x and g of x equal to 1 by root x in a comma b. Introduction to Cauchy's mean value theorem. Cauchy's mean value theorem is a fundamental result in calculus. It establishes a relationship between the derivatives of two functions and their values at different points. This theorem is named after the French mathematician Augustin Louis Cauchy. Statement of Cauchy's mean value theorem. Cauchy's mean value theorem states that if two functions f of x and g of x are continuous on a closed interval a comma b and differentiable on the open interval a comma b, then there exists a point c in a comma b where the derivative of f of x divided by the derivative of g of x is equal to the difference of their values at the endpoints. Mathematically, it expressed as f of b minus f of a by g of b minus g of a equal to f dash of c by g dash of c. Applications of Cauchy's mean value theorem. Cauchy's mean value theorem is often used to prove other important theorems in calculus. It can be used to establish the existence of certain values or solutions. This theorem is particularly useful in analyzing functions that involve fractions or ratios. Example functions f of x and g of x. Let us consider the functions f of x equal to root x and g of x equal to 1 by x. Both f of x and g of x are continuous on the interval 0, 1 and differentiable on 0, 1. Calculating f dash of x and g dash of x to apply Cauchy's mean value theorem, we need to find the derivatives of f of x and g of x. For f of x equal to root x, we have f dash of x equal to 1 by 2 root x. For g of x equal to 1 by root x, we have g dash of x equal to minus 1 by 2x root x. Applying Cauchy's mean value theorem. According to Cauchy's mean value theorem, there exists a point C in open interval a comma b such that f of b minus f of a by g of b minus g of a equal to f dash of c by g dash of c. This is the formula of Cauchy's mean value theorem. Substituting these functions f of x and g of x and their derivatives, we get square root of b minus square root of a by 1 by square root of b minus 1 by square root of a, that is equal to 1 by 2 square root of c by 1 by 2c square root of c. Simplifying further, we obtain square root of b minus square root of a into 2c square root of c by 1 by square root of b minus 1 by square root of a equal to 1. Solving for c. To solve for c, we can cross multiply the equation square root of b minus square root of a into 2c square root of c by 1 by square root of b minus 1 by square root of a equal to 1. This gives us square root of b minus square root of a into 2c square root of c equal to 1 by square root of b minus 1 by square root of a. Simplifying further, we have 2c square root of c into square root of b minus square root of a, that is equal to square root of a minus square root of b. Conclusion. By applying Cauchy's mean value theorem to the functions f of x equal to root x and g of x equal to 1 by root x in the interval a comma b, we can find the value of c. The equation c equal to square root of a minus square root of b by square root of b minus square root of a by 2 root c allows us to calculate C using the given values of A and B. Cauchy's mean value theorem provides a powerful tool for understanding the relationship between the values of two functions and their derivatives in a given interval. This is about Cauchy's mean value theorem. Thank you, ma'am. Thank you for giving this opportunity. Thank you.